this just becomes the y. I don't know why it's telling me this stuff late. I hope it's not messing up. Okay. And we already know the integral of this is f of x plus c. So this is called differential equation because this is a differential. So this generates a family of curves, but sometimes we want a specific curve, like a curve that passes through a specific point, x naught, y naught. And we're going to have like y of x naught is the same thing as f of x naught, which equals y naught. This is a bunch of different types of notation for you see for the same shit. Just wanted to call your attention to it. And then we'll use that point, it's called the initial condition, to find out what C is. So that rather than saying a family of curves, we can pick out the specific curve that's part of the family, as you'll see. So let's say dy dx equals cosine x and y of 0 equals -3. So what we're going to do is we're integrate both sides and we get y equals sine x plus c. And then this is my x. I'm going to put that in here. This is my y. That goes here. And I have -3 equals sine of 0 plus c. Sine of 0 is 0, though, so I see that c equals -3. I'm going to go back and replace -3 right there. And I get y equals sine x minus 3. And I don't have the c anymore, notice. That's an initial value problem. Let's take a look at another one. Let's do 4x to the -3. And we're going to have when x equals 1, y equals 3. So we integrate both sides with respect to x. That's the terminology for it we're going to be learning. Integrate both sides with respect to x. And with respect to is often abbreviated as WRT because you say it a lot. So what that line means is put the integral on with the dx. Put the integral on with the dx. That is integrate both sides with respect to x. Okay? So we're going to do that here. We integrate the left, we just get y. Here we go up a power and we divide by the power. 4 divided by -2 is -2. And I rewrote this as x squared on bottom because that's what the -2 exponent does. Then we're going to use the initial conditions. The 1 goes down here. The 3 becomes our y. So I have 3 equals -2 over 1 squared, and I solve for c. I get c equals 5. I take my 5, I put it back in c, and I rewrite the equation without the c in it. All right, let's look at a harder problem. A car is traveling at 88 feet per second, which is 60 miles per hour, when the driver starts braking, slowing by 15 feet per second squared. How many seconds until the car stops? How far did it travel after the brakes were applied? So we have that they're going a speed 88 miles or 88 feet per second. This is like an initial velocity. This is like V0 equals 88 feet per second. The 15 feet per second squared, that is braking. They're slowing down. So if the speed was positive, braking is slowing down. We're going to call it -15 feet per second squared. And that, since it's changing the velocity, that is a change in velocity, which is acceleration. We're also going to say the position of the car when they start braking is 0. That way we can figure out, like, it makes it a little bit easier to figure out how far they've gone for part B. Okay? 0 gives us an easy starting point. So we start at this. We are going to integrate this. Remember, A of t is the same thing as dv dt. So we integrate dv dt and we integrate -15 feet per second squared. I did not put an integral there. Look at that. Look at this slacker. Integral. So the left side becomes v of t. The right side is negative 15t. It was a constant, so when it goes from a constant and we integrate, we just slap on the variable. That shows up right there. And now to figure out c, I use my initial velocity. V of 0 is 88. I'm going to replace my t with 0. So 88 is going to equal negative 15 times 0. I just get c is 88. So I'm going to take that and I'm going to plug that back in before I do the next step. Okay? So if I want to go from this step to the next step, what I need to do, and apparently I felt like not showing it there, so let's add it in right now. I integrate both sides with respect to t. That looks shitty. There we go. That looks a little bit better. Integrate both sides with respect to t. The t goes up to t squared. We divide by the 2. We've got the 88. It gets a t and we add a c. We're going to use our initial condition to find out what the c is. If I plug in 0, I get that c equals 0, and that goes away. So s of t is just negative 15t squared plus 88t. Now we can start answering the questions. Now that we've got our systems of equations, we know what everything is. Acceleration is here. Velocity is not rewritten. I didn't rewrite it. Look at this. So I just slapped the integral on it. Maybe I shouldn't have. Let's write down the untouched velocity function there real quick. So we have our acceleration up there. We have our velocity right here. And we have our position function right there. So when the car is stopped, how many seconds until the car stops? When the car stops, velocity is 0. So we can use that up here to help find out what t it stops at. So we're going to say set v of t equal to 0. Negative 15t plus 88 equals 0. We solve for t. T is 88 over 15, which is about 5.867 seconds. I used 88 over 15 for my next step because when it finally gets to that velocity of 0, we can figure out how far it's traveled if we plug that into s of t. So I'm going to take that 88 over 15. I'm going to put it in here. And when I actually did some multiplying out by hand, it gets down to 88 squared over 30. If you had jumped straight to doing this, you would have got 258.133 feet. So that's kind of how this works. And that'll be this for this. Now get up there and study, study, study. We got a test coming up.